system, which will be to the topic for more details. From the cervical ganglions, sympathetic fibers coming both into the atrial and ventricles. SA node, AV node, conducting system, Purkinje fibers, London branches. These are the conducting system. SA node, AV node, Purkinje fibers are part of the conducting system. So, from the cervical ganglia, which are part of the sympathetic system, nerve fibers coming into the heart, both in atrial and the ventricle. When the sympathetic system activates, from the nerve endings, norepinephrine is released and acts on different receptors on the heart. Via beta-1 receptor. Beta-1.
Beta?
Yeah.
What is beta?
Beta. Beta.
Beta?
Yes, beta. Beta-1. Beta-1, 2, alpha-1.
Okay. Thank you, sir.
Beer.
There are quite a few beta-1 receptors on the heart, then activating by norepinephrine. It can activate adenylate cyclase. Adenylate cyclase convert ATP into cyclic AMP. So there is an enzyme called adenylate cyclase. Norepinephrine acts on adenylate cyclase, and acts on beta-1 receptors. When activates beta-1, adenylate cyclase converts ATP into cyclic adenosine monophosphate.
What is the sound?
Cyclic adenosine monophosphate. What's the question? Acts on beta-1 receptors. This enzyme connects to the adenylate cyclase. When norepinephrine acts on this receptor beta-1, it can activate adenylate cyclase. There is an enzyme. When this enzyme activates, it can convert adenosine triphosphate into cyclic adenosine monophosphate. This cyclic adenosine monophosphate is the second messenger and can phosphorylate quite a few enzymes and proteins inside the cell. Can phosphorylate, can activate quite a few enzymes inside the cell. So cyclic AMP is a second messenger. So beta-1 activates, adenylate cyclase activates, cyclic AMP forms. This cyclic AMP can phosphorylate sodium funny channels and activate them. Can activate N-type calcium channels. Can activate transient type calcium channels, N-type, T-type.
Can I repeat your name?
Which one?
The hospitals.
Sodium funny channels, we have discussed it. Sodium funny channel. Or what we can find in the book L-type calcium channel. T-type calcium channel. We have these different types of channels, sodium channel and calcium channel in the body. We have also potassium channel, different potassium channels. So if you activate beta 1, these channels can be activated. When more sodium coming into the cell, then the time gap between the resting state till to the threshold will be reduced. This is called diastolic depolarization. Resting depolarization or diastolic depolarization. The time gap that is needed to reach the resting state to threshold will be reduced, and the heart rate will be increased. This is the mechanism of action of sympathetic activation in the heart. So at the nerve ending of sympathetic fibers, norepinephrine is released. In the bloodstream from adrenal gland, adrenaline is released. Adrenaline can act also on beta 1 receptors and have the same effect. Adrenaline in general circulation and other hormones can act on these receptors.
Now please can you repeat, you said at the end of nephrin, sympathetic nerve?
At the nerve endings, sympathetic nerve endings, you have some varicosities, some vesicles in which noradrenaline is stored. When a signal, when an impulse reaches to the nerve endings, these vesicles will be ruptured. Norepinephrine is released. When it is released, it acts on beta 1 receptors, activates adenylate cyclase, forms cyclic adenosine monophosphate, activates quite a few enzymes. These enzymes phosphorylate sodium channel, L-type calcium channel, T-type calcium channel.